Hello, everybody. Welcome to one more session of the KIELives, which is a series of lives dedicated to talk about the projects under the Key umbrella, like JBPM, Drools, Planner, and more recently, Cogito. So we have today a special guest who's a consultant from the EMEA region. He's working with Java for more than 19 years and as a consultant for more than 10. So he has seen all sorts of issues around the globe, delivered enterprise architectures using not only the business automation stack, but also integration and orchestration platforms like OpenShift. So I'd like to welcome Paulo Menon. Hey, Paulo, thank you for being here with us today.
Hi, hello everybody. Thank you, Karina, to have me here. It's been a pleasure to come here and present. And I'm very excited today to show you guys the demo I've been working on. And just quickly review of our presentation session today. We're going to focus in one type of integration with GPPM. So Karina, can you explain the other types we're going to left for another day or another discussion?
Yes, of course. So for those who are not aware, Red Hat PEM, which is also known as JBPM, JBPM is the community project and Red Hat PEM is the enterprise product based on JBPM. So, Paulo Meno. So you can use different types of integration with Kafka with this project. So you can, for example, emit messages using the message events from the BPMN specification. You can start new processes by using the start message events, also from the BPMN specification. You can use intermediate message events to throw or catch events. And you can also use Kafka to audit every transaction that happens within your processes, cases, or tasks. But this is not the focus of today's talk. Today, Paulo Menon is going to talk about how you can use a Kafka task to emit events from within your process, right, Paulo?
Yeah, that's right, Karina. And thank you for the whole explanation.
And I
So
think you're even going further because you're going to integrate with Influx DB, Grafana, and you're going to do a whole thing, right?
yeah, it's a very nice demo that I was planning, and I have some help from Ingo Weiss, was one of our engineers, to create some little components to build around the BPM. And he's not here today, but I'm gonna cover the whole demo. And yes, it's based in a real use case that I've been working in a few customers that they gonna relationate with this use case in several business. So it's most like on a public sector base, but I will let that to explain when I start showing the slides.
Awesome. I'm looking forward to it. So, guys, as usual, feel free to drop all your questions on the chat. And by the end of the presentation, I'll bring the questions over to Paulo, okay? Menon, you can start sharing your screen and a good presentation, okay?
Thank you.
We can see your slides now.
All right, thank you. So what is the problem I'm trying to solve it today? So I was thinking a lot of time about what the problem we have when we start building BPMs and process flow. So the BPM process flow is the way we can extract the information from the BPM that tells you about the stage of that process and what the pending process, if they are in progress, or if they're ready, or if they complete or abort. So any of these informations is something that I don't care about in this demo. So what I'm looking for is to actually get the business information from the BPM, how we can fast feedback the business. So extract the business information that is running on the BPM process, and how we can collect these business metrics. So it's not the metrics from the BPM, so but collecting the business metrics, and deliver the customers metrics to the different system. How we can feed like Kafka, and in this case, and create a data partner to support the business decisions, so that you give you the business quickly information from the process that can make them take the decisions quickly. And in my case, so when I was thinking on this problem, I thought, why we don't integrate that with Kafka to collect this information? I know the GPPM has his listeners, and you can use the listeners for several things, but I want to get like a hands-on on the creation with Kafka and integrate with Kafka Streams. So let's see how this goes. So in my use case, I put a agricultural claim founding application. So to illustrate this use case, so basically this use case is a farmer, like this one we have here, which is Tyron Lannister. And Tyron Lannister needs a new loan for buy 2 new trucks, right? And we have another farmer, which is Sansa Stark. And Sansa needs the loan to build a new barn. So basically they're gonna fight each other to conquer the whole Westeros and all the farms, but before that they need to apply for funds on the central bank. So that's basically our use case. So the farmers that need to request the loan through this application, and the process to get this is the process we're gonna demo today. And this is our use case. So what we're gonna do is we have a fictional country with a fictional government, central government, that's gonna fund these farmers and give budget to different regions. So so what we care about here is the distribution of the budget. So it's a very normal case inside of companies. You guys probably seen this before, like you have working in one area of your company that need to request a budget, so need to apply and request approval for that budget for the project. And so this can also be ported to a company controlling the budget within the company, within the areas. In our case is like a fiction government send funding to different areas in that country. And so then what we care about is the distribution geographically that budget. So we're going to see like north, west, and south, how much that gonna get the budget. So we're gonna extract this information from the BPM and have a nice way to display it. So then we're gonna simulate the user, the customer, which is the farmer, which is gonna send the farm application, the found application, kick off several claim found process. So they're gonna, we're not gonna focus in nothing in the UI, but we're gonna simulate this kickoff and interact with the REST API. Then we're going to simulate the internal staff member. So this is the staff member that's going to validate the application, going to go there and check what is inside of the claim found process. And we're going to simulate that part because we don't want to focus on a GPPM form and show how to fill the form and stuff. We just want to focus on the integration. So the GPPM task simulator, the task automator, gonna just generate the tasks and then randomly gonna create approvals and rejects. And then finally, we're gonna get this information with an integration process that's gonna feed in Apache Kafka, and we're gonna display this in Grafana. So the analysis of the data we are caring about on this demo is the custom metrics. So the custom data, the business data that we can extract from the BPM. Then collect this valuable data, which is gonna help the business, feed external system like Grafana, display metrics for analysis on, feed the external system with Kafka, and then display metrics for analysis in Grafana. And then facts to support decisions, right? Because we want real facts, real information, and real-time information from the process that can help the business to make decisions. So then, in the end, the result is you can improve your business process, see bottlenecks and other stuff, and also the value of the information that is given for the BPM. Right, so the overview of the solution, let's check the diagram of the solution. So like I said, we're not going to focus in an UI part of this process. We're going to just demo the backend. But the GBPM key server is easily attached to any UI. So any like Node.js, any JavaScript UI you have, Angular, anything like mobile apps, anything you can create it there, and then you can connect with the GBPM key server because it's all REST APIs being exposed. We're going to have the GBPM key server has its own database, which in this demo we use Postgres, and they're going to be integrated with Kafka Stream using StreamZ for the operator to deploy on OpenShift, and a Kafka bridge, which is going to be the bridge with the consumer going to read, prepare the data, and save on the InfluxDB. And then the analysis tool is Grafana, which connects to InfluxDB through a data source. And then we have this as little systems to data generator and task automator that are going to get to that in a few slides. So deploying on a Kubernetes. So the Kubernetes is the platform we choose for deploying the demo. So what we used was the Orange, the community distribution of the Kubernetes, which is the OpenShift community version of the OpenShift. And you can find that easily in the internet. All the links I'm going to give it to Karina, and she can put on a description below later on. So that's the tool we decide to use our platform to have everything on the cloud. So we have the platform as a service tooling, which is the Orange, and then the foundation of all the deploying of our applications. And what we deploy there, we deploy the GBPM key server, the Apache Grafana, Apache Kafka and Grafana, and other components like Postgres and so on. So the StreamZ is the operator. So if you're not familiar with the operator, so we're not going to get deeper on the operator side, but StreamZ is the operator to deploy Kafka on the cloud, on Kubernetes. So you can use the Kubernetes way to deploy the Apache Kafka. It provides three operators: the cluster, the topic, and the user, and the cluster and the topic are defining objects in the Kubernetes. So it's an easy way to deploy, and the operators watch a namespace that you define, and then if you change the cluster, he reacts quickly and change the cluster for you. So this all supported distributed using Jaeger. So there's a overview of the StreamZ architecture on the operator side. So I'm not going to go deeper on that because it's going to create a whole different discussions and sessions, but I'm happy to go there in another opportunity. But it's basically you create an operator that deploys the Zookeeper and the Kafka cluster. So when you change the topics on the operator, he reflects and creates the topics for you on Kafka, and then you can change the cluster. Said if it has 3 nodes, you change to 2 or change to 4, and the namespace reacts, and then you can watch more than one namespace. And so all namespace are spaces on the Kubernetes. So then what we're going to focus is the GBPM with the integration with the Kafka. So the GBPM is the component that you guys are probably familiar. If you are following the channel, the KIELive channel, is executable process modeling that you can drag and drop and build your executable model of your business process that implements the BPMN2. And it can, nowadays, you can run in different runtimes. You can run in JBoss AP, which is the Whitefly, and Spring Boot and Quarkus, which is the Cogito, something. So that's also another video. But process the design. So we have the process design, which is seamless process modeling. Is based on a BPMN2, so it implements the whole BPMN2 process execution. And it also has a extensible palette with custom service, which we're going to focus for the Kafka integration, and it's also extensions for the case managed capabilities. It also can have the form generation, but we're not going to see that in this session. And you can export the PNG, PDF, and BPM2. So this is the tool we're going to demonstrate today, we have the VS Code plugin for that. You can develop your modeling, your tool in VS Code. We also have a UI-based tooling to create this on the fly. But today we're going to go to the workbench using the Business Central workbench with the GBPM workbench. So they give you all the capabilities and the drag and drop tool that can build the BPM. So the came from process, let's check the main process model for this demo. So I create a small process just to illustrate and create quickly show how we can integrate with Kafka. Like we said from the beginning, you have different ways to integrate Kafka and interact with Kafka via the GBPM, but that is one just to publish using the work item handler that we're going to get to that in a few slides. So the process is going to just like start, set up some values, publish some information to Kafka. Then we have a user task, which is the claim found approval. And this is a wait stage. And then you have a gateway with that going to approve and reject. And then depends of what the staff decide, then you go to different paths. So the GBPM service task list, that's what we use, the work item handler for publishing Kafka message, is all available in the tool. It's a service task list component. So when you go in the workbench, you go to settings and they have a service task, then you can find the Kafka publish, and then you put on and then install that for you to use in your process. But let's say if you has more in this list, so I just could capture the whole list. This list is very extended. And if you don't find anything here, we have a GBPM GitHub repo with all other work item handlers, which is all the custom nodes for you. So you can like do a git clone from that repo, build your jar, and then put inside of the loading in a tool, and then you can set to on and then configure it, and it's available for you. If you don't find anything there, then you can create your own. So you can create your custom work item handler, which will be your custom node. So you can create that from a Maven archetype. So it's basically that the Maven archetype code, the initial code. So you just need to code what you wanted. And on the part that says sample parameters is the parameters you're going to collect from the process, and then you can do some complete work here. So you implement what you need. I have worked with different customers, and sometimes what they need is like a SOAP integration, so they can create a SOAP call from the BPM process, and then they create the custom node, especially if you have like extra security features to check or retry mechanisms and stuff, so you can create all that on your own work item handler. And that is the GBPM work item archetype, so it's a Maven archetype. You can change the code like I explained you. Then when you change, then you build it, your jar file, upload to the tool, then it's ready to use. And then you can be, like I say, ready to use. Then you can be drag and drop in building your process, reusing everywhere. So the Kafka process integration is the process that the main process is going to call. So I decide to create a small process, and in this small process, what we're going to do is the main process call that and send parameters, the process parameters. So it's all parameterized, the top key and the host and the message, so the payload of the message is all parameterized, is all built there on the preparing payload, and then the Kafka publish just send to the Kafka top key. So it's part of the service task list, so you can see is that palette there, so we're going to show that in the demo. And then is a reusable, you can integrate with any other process, you can drag and drop, and a configurable way to publish message on the Kafka. So of course you can build your own Kafka web service, you have your consumer and your producer, you can Camel or a Spring Boot, but this way you can actually do that quickly because it's already ready for you. You just drag and drop, put the top key queue and the payload, the body, and it's ready for you to use. So the Apache Kafka, you guys probably know, Apache Kafka is a publish-subscribe messaging model, which is a like centralized streaming messaging. So the different from the like a broken message is a very heavily on I/O, and is nothing in memory, is all like reading on file system, and is pending message. So when the consumer reads that, you don't lose the information. So the cluster is formed by brokers in Apache Zookeeper server for authentication, and it's really easy to distribute across clouds, especially using the StreamZ operators. And that is the Apache Kafka architecture I took from the Apache Kafka web page. So that's just to explain you that you can have several apps connected to their Kafka cluster, sending informations to top queue, so the producers, and you can have like several apps as a consumer doing different things, so they consume from different topics and do different jobs afterwards. And you also can extend the Kafka cluster and connect with connectors and connect to your database and create a little audit from the tables you want to check. So when you have like different entries on the database, then that can be feeding back to a top key queue. Then you can create graph key reports, audit reports from the database as well. So Apache Kafka is a very powerful streaming tool and integration tool that I really like to work with. And in our case, we use the InfluxDB, which is a timer database. So we need to decide which database we're going to put the customer information. And it's a time series database, which is easy to extend all the things. We have like two data that we measure there, is the loading updates and the budget updates. And then Grafana has a support out of the box. It has a data source to connect straight to InfluxDB, so it was easy to collect information we put on the InfluxDB. It also provides a Kubernetes operator, so it's easy to deploy on OpenShift and Kubernetes. So these are other components we have, just to illustrate to you. The GPPM, when it's integrated and publish information to Kafka, he used two top key queues, a loan updates, and the budget updates is the top key queues. And what you see in green is the Kafka bridge, which is a consumer that written in Camel that reads the information from the top key queues, preparate the data, do all the data conversion for the format that the InfluxDB needs for the writing on the database. So then we write it on the database, and Grafana collect information from InfluxDB. So this is a little bit of the code in Camel, for you guys can see that is a Camel consumer that gets the information from the top key queue, from the load queue, and then save that on the InfluxDB. And then the reason we choose Camel is because it's easy to create an integration layer that reads a consumer that can read the information. Then you can arrange or prepare the data, change the data, and put on a format that the database tables needed, and then we can just update the time database to InfluxDB. So that's the other components we have. The data generator, which is running local, is a small Java application. We're going to see this in this demo. And what this does is simulate the creation of the tasks, the creations of the process. Like I explained in the beginning, it sends the task, creates payloads, and then randomly creates the amount of budget you're going to request for the application. So skip the part of have like a UI or a form to create the application request. So we all running that in the small Java application to generate this data. Then we have the task automator, which is simulating the running of the staff member that collects the task list, and then he claims, and then he starts the task, and then he completes the task. And then this running also locally is just a Java process, and they all communicate with the key server via the REST API. And that's the Grafana, which has our dashboard. So we're going to display two dashboards for you guys to see, and you're going to see the regions and the rejects and approvals, and also the budget utilization on this little clock. They're going to show how much it was increasing the use of the budget for region. We put a limit for that to illustrate, and then we're gonna collect this information, show that in the demo. So we put 10 seconds to refresh. So just give you a nice way to see that all simulated quickly on real time. So now we're ready for the demo. Do we have any questions before we jump into the demo?
We do have a lot of questions, but I think we can wait until the end. You can show the demo.
All right, thank you. So let's go ahead. So I pre-prepared this demo here for you guys. So that's to show where our platform, the container platform, the cloud. So we deploy there the Grafana, InfluxDB, and the Kafka bridge, which is our consumer. Then the claim found key server, which is the key server, the GPPM key server, where our process is running. So the key server also provides you the Swagger API, so that you can explore all the REST APIs, like for the case or the process APIs. And the process, the Business Central, you can see where is our project. And let's go and check the process, the main process, the claim found process. Let me click here. Right, so I have this process that sets up the values. So when you kick off, we're going to set up the values, going to publish the status of the application which is pending. So that in that point, we call a Kafka subprocess. And then claim found approval task is a wait stage, is a user task. Someone needs to interact and give you the approval and the reject. So we're going to simulate that randomly, and randomly he's going to go to approval or reject. So if he goes to approval, or he's going to go to reject. Let's see how this going to play. So if he goes to the reject path, then he publish a status reject on a Kafka topic. And if he goes to the approval, he's gonna simulate this money transfer, like getting the money transfer from the whole amount of budget you have, and then the publish status gonna change to approval. So we're gonna publish a new status on Kafka, and publish the remain budget for us to calculate. So these nodes there, I'm going through with the mouse, is the ones that call the subprocess. So let's just go a little bit back here on the beginning of the process. And let me show this. All these ones here that has this cross there is the ones that do a call to the subprocess. So that's just to show that you can do a reusable subprocess and see the Kafka integration subprocess. Let's close this one and see the subprocess. Let's click here and open the Kafka integration subprocess. In this way, you can reuse it with like different main process can call this one as well. So that's going to kick off, start, preparing the payload, and Kafka get published on the top key of the information you send, because it's all parameterized. And the Kafka publish is available in a palette you have. So it's there in the work item handler. So you can drag and drop. You just click, drag and drop, and then it's ready for you to use in your process. And just let me delete this one, and let's check the process configuration for this. Then you guys gonna understand how it's been passing the parameters. So here I can show the data, that the process parameter. So we have the top key and the value, which is the payload. So these two are process variables, and they get parameterized, and information get fed from the main process and then sent down. So then dynamically, I know they go to different top key queues in different payloads. So let's see the Grafana dashboard. So let me explain. This Grafana dashboard is the one that can show the different regions. So it's regions from like west, east, south, and north regions. We choose regions in Scotland for some reason. And this is the clock that shows the consumed budget. So if you're still in green, means that you're still in a good way. So if you start going to yellow and red, then means that you're getting running out of budget. So if you stay here in yellow, you need to start stopping because you don't want to go to red and lose all your budget. And the good thing about this, we also have this another dashboard because you show you the totals here, and we're going to show also the pie chart from the utilization of the budget. So you can see like a percentage of the budget being distributed by all these regions. Then you can see which region gonna get more budget. So let's go and start here. So first I'm gonna start the Java process that's gonna kick off the process and generate some tasks. So it's just gonna put 30, and then you're gonna generate 30 process that's gonna be running. And let me just press start, and then he's starting creating. So the tasks that you see is just a counter. So it's not the task IDs like some people are familiarized, like task IDs or process instances. We're not displaying this, that. It's just displaying that we're sending post requests to kick off the process. And as you can see, all the pending stages are starting showing up on the graph. Because if you go back here to the process, if you guys remember the first part of the process, he published pending states on Kafka. Kafka had been reading by the consumer put the information on InfluxDB, then the Grafana is already pulling this information out and put there. So we are stopping there in the claim found approval task. So now we need to approve or reject. So we have another process that we're going to start moving this pending process across. And so to move that, we have another Java process we want to run, which is the task automator. So we run that, and he's going to start collecting the first 10 tasks, and then randomly decide if he's approve or reject. Right? So if you just press the start, and then you can see he collect the first task, and then you can see the first 10 task IDs, and then he claim the tasks, and then we're gonna start that tasks and complete all the tasks. So a few of these tasks gonna be approval, a few gonna be rejected. So let's check how this affect our charts. So you can see he randomly pick up some of these tasks and start approving, reject, and you can start seeing the graph keep showing, increasing of the use of the budget. And if we click again, he's gonna collect another 10. So remember, we create 30, so we're already using 20. So we're gonna see all these other pending moving, because it's all random where we're getting this task in and approving or rejecting. So now he's gonna give you a little bit of time. He's refreshing pump. So you see it's moving to approval and reject, and the budget have increased the use of the budget. So if we run again and get the other 10, so we're gonna use the left 10 tasks. So you start claiming. So claiming is the action that is reserving these tasks for himself to use. A user that's reserving this task is a customer, is a staff that connect to the process, reserve this task, and then complete it. So now you can see the total. And so you have the approval, rejects, and so the total use per region is the sum, is the whole sum of the budget being used on these regions. So if you can see here is regions from Scotland. So if you're familiar with Scotland, so that's a pie chart. Is you can see for the percentage, and that's give you right to the business the information they need to take decisions. If they can see there is a region that is getting more budget than the other region, that they can start like frozen the budget they want to give to one region and then start giving to another, and vice versa. And also, like if they are seeing that they starting running out of budget, they need to froze the whole program of founding farmers, then they can stop that and they can readjust it. So react quickly to take decisions, right? So if we go there and let's try to, yeah, it's all like the totals here basically. And if you see here, it's starting moving, and then you can see the maximum. I'm running the process behind the scenes. That's why it's still like loads of pending process. And let's run another 30. So creating more tasks, creating more applications, like submitting applications to the loan applications. You are asking for the loan, like, and is simulating the customers asking for that, and going all to the pending stage, and then the staff member need to go there and decide who needs to get approval or reject. Then you collect another 10 and start claiming this task. And the good thing here, the user task, is a wait stage, is when a human need to interact, a human being need to interact with the system and give the approval and reject. A classic example of that, like when you submit a loan application, you need to submit your documentation, your IDs, and someone needs to look at your picture and make sure you didn't upload your cat picture. So you can see the approvals and rejects being moved as we do more tasks and create more tasks and apply more the task automator. He started moving more the tasks around approval and reject. So I just started another 200 tasks. I'm not going to be here forever, don't worry. It's just the last interaction we're going to do, and we go into the questions, right? Let's just finish this demo first. So just another quick call for another 200, and then we collect another 10 tasks. So claiming the tasks, right? Then you can see the budget utilization going to increase. And that's what we want to see in the demo, right? You want to see Grafana collecting in real life information from your GPPM with all this integration nicely integrated with Kafka. And you see the budget utilization is going up, you get more approvals and reject, and because it's running behind the scenes, creating more tasks, and then you're going to continue creating tasks. So from the demo, we're almost there. So you can see the chart pie. So the pie chart is not already in Grafana, so you need to install that plugin. And one thing I want to show quickly, so what we use there to support this demo and help us to test is Postman. So most of you guys probably are familiar with Postman. Is a REST client tool that you can use to test your process. And it's a very nice way to test your process. Why? Because you can have all the REST endpoints here configured, and you can parameterize the URLs, your container ID, and your process ID. And you can test from the local environment or from the OpenShift environment, and then you change, and this environment variable is going to change and start pointing to a different endpoint, to a different container, to a different process instance ID. So you can easily change configuration. So we use that to do a one interaction to our local environment, to the OpenShift environment, and you can have a different namespace, and that's easy to actually export all these endpoints with all these parameters. You can easily export and give it to a member of your team. So that's all I want to show to you guys today. Thank you. We can see if we have some questions.
Hello, Menno. I already stopped sharing your screen, and we have a couple of questions here on the chat. Everybody was just saying, great demo, and looks like you have lots of friends here. So, first of all, why did you use OKD instead of OpenShift?
So the aim of this demo is only use community versions. So OKG is the community version of OpenShift. So we decide using all open source, the community products, like GPPM is the community version of the Red Hat process automation, and StreamZ Kafka is also the community product. So in Red Hat, we have the MQ Streams, which is the product from Kafka Streams. So then, yeah, that's the thing. We decide to use all community, make as much community easy. Anyone can go there, download. It has the source code.
Yes, and there's also another thing, and I think that OKD is based on OpenShift 3, and also currently we also support OpenShift 4, right?
Right, that's just true. So when at the time I'm gonna building this demo, I just decided to use the OpenShift 3.1, 3.11, which was the latest family of the OpenShift. But we support this on OpenShift 4. The tool support is on OpenShift 4. The operator is working very nice on OpenShift 4 either. Actually, the operators work better on OpenShift 4.
Yes.
Right? Because it was meant to be using operators on OpenShift 4.
And where did you configure the connection to the Kafka brokers? Is it done in the server level, in the project level, or in the task level?
So the configuration to connect my GPPM to the Kafka broker is the work item handler that is already there. So you drag and drop, and he has already installed there and has a settings that you configure the marshalling class. And then when you drag and drop input in your process, what you need to do is put the top key and the payload you want to send. So beforehand, you create the top keys on Kafka, and then you know the top keys you meant to send. So dynamically from the main process, we are changing the top keys and sending parameterize and tell me, hey, I have this process parameter called top key, and then he receives which top key I need to publish. So that's the way we configure it, all configurable from the publish Kafka work item handler.
Perfect. And what about the payloads? Because I see that you have a task there, process the payloads, and that was something that people were interested in. How do you process that? Like, what is needed to do in there? Because you have all the process variables. How do you put that into a Kafka message?
Oh yeah, the body, right? The payload body. I was building dynamically on that script task, so I just get the parameters of the body, which is like the user send approval and reject. Is a very small payload, to be honest. So if I was doing a massive big payload, I would have like my own custom work item handler, because when you create script task, you're not able to debug inside of the script task. You don't want to bury business logic inside of your business process. So if it was a big payload building and like collecting information from other places, then I would have like a working item handler to customize that, or even basically like call a web service to create a payload.
Perfect. And I think that this demo showed a lot of the flexibility of the different architectures that you can use, because for example, instead of using Prometheus, you used InfluxDB. Instead of using Dash Builder, you use Grafana. So the people can actually select what tool fits best their environment. And there's one question from Luigi here. He says that you had a DB in one of the slides. What is the reason that you're using the database?
Right, so we have two DBs on a slide. We have Postgres database, which is the GPPM database. That's going to storage the status of the process. So that wait stage, when it goes to the user task, is all persistent. So all this process definition all the process variables and values get created in the tasks IDs and process instance IDs are saved on the BPM tables on a Postgres database. It can support different databases. You can use MariaDB, you can use MySQL, Oracle, SQL Server. So it is up to you the flavor of you want to use. It's easy for us with the Postgres because it is open source. And so we have a template that deploys the key server and the Postgres, and is already configured the data source to use that database. The other database is the InfluxDB, which is a timer database, so it's easy to update. And then Grafana has a native plugin data source to the InfluxDB, which is easy to connect Grafana to that.
Perfect. There is a question from Diego Torres.
Hello, Diego. How are you doing?
So he says, like, about the, because on the beginning of the live, I said that we can use Kafka to audit our environment. And he asked, like, so about the current audit mode that we have for JBPM, is it recommended that because you were using this Kafka tooling and analysis, should we set it to none? Because like in PEM, we have different ways to configure. We can set it to none, JPA, JMS, and now we also have this other configuration that is Kafka. And yes, I do think that we should set it to none. And I think then you can let me know if you agree with me, Menon, because if you set it to none, you will reduce the amount of transactions you do to the database, because all the transactions that happen for processes, tasks, and cases will already be sent to topics, to specific topics, and then you can handle them in client applications. So you can reduce the amount of database maintenance, in those sorts of things. So yes, I think that's a good idea, Diego. Thanks for bringing that up.
Yeah, I agree. That's definitely the best approach.
So there's another one, and this will be the last one. So from Luigi, are the tasks stored on the Kafka queue when they are in pending status? So I think we can switch this a little bit, Menon, because are these tasks that do they wait something? Are they async? Because he asked like if the task is in pending status, but I don't think the task waits, right?
No. So why we publish on Kafka is not the status of the process. So it's not the status of the tasks. So we in the beginning of the presentation, I was explaining we're not interested to collect the metrics from the GPPM because we have dashboards. We can use the dashboard and show how many tasks are pending, how many tasks are complete and abort, and so on. So why we are focused is collecting the status of the application form. So if the farmer was submitting the application for request the loan, and that's the status we are publishing on the loan topic queue. So we are putting the status of the application status, so the business keys. So that's what we publish in there. So it's not async because it's all business information we push into Kafka. So when he completes, so the sync we did because of the flow, because it's pending and then gets to a staff member to work. So it's basically it's pending that task, but it's nothing actually configured to sync anything. It's just because when they decide to approve, then we update the approval status on the queue, and then the consumer reads that and move on Grafana.
Perfect. Thank you, Menon. So, Menon, I really appreciate your demo here today. I hope that you can join us more time to show more of what you've lived in the field and bring more of your experience. So, there's final question, okay? What are you drinking? Where is your beer?
Right. I'm drinking water because I run out of beer this weekend.
Awesome. Okay,
I didn't have time to buy more. So sorry. I have one bottle of vodka, which is my daughter's bottle of vodka. So I'm trying to steal it, just waiting the right moment. And,
awesome.
But just one thing I want to say is thank you, everybody. Thank you, Karina. And I decided to use the InfluxDB and don't connect to Prometheus, but the tool actually has support to connect to Prometheus. And you could connect Grafana to Prometheus and collect the information. It's just, I like the InfluxDB. I want to do something with it. And then we did this demo. And thank you, Ingo, which is helping me with some points and things on the demo. And Greg helped me before because he set up the OpenShift platform in his house. So he put in his own hub there to run the OpenShift for us to run. But he's difficult to reach to him right now because he's busy working elsewhere. But he's a really nice guy, and he helped us to run the demo and prepare everything.
Awesome. So after we wrap up, I will ask you the GitHub link so I can put it on the video description because people want to see a little bit more of the code.
Yes, for sure.
Yes, thank you a lot.
Yeah, the GitHub. We're gonna I'll give you all the repos.
You can send it to me once we wrap up. Okay.
Right. We have the demo in one repo. We have some things in another repos and stuff.
Okay, perfect. So thank you a lot. I wish you have a great day, Menon.
Thank you. Thank you for having me. Thank you guys for attending. See you.
See you. And for you who's here, we have more cool KieLive scheduled, and I will put it on the link on our site today. So if you enjoyed this session and you want to know more about the projects under the Key umbrella, make sure you follow this Eventbrite link that I shared there, because every new event that we post will go out there. Okay, so I'll see you next on the next KieLive, and have a great day. Bye bye.